Take 6. All right, hello and welcome to another edition of Pap's Rockets. I'm Pap, and I want to describe the components which make up a 4-inch Avionics bay. Now, there's lots of products on the marketplace. I prefer LOC precision components. Very sturdy, great selection, great to work with if you want to design and build custom rockets, which I did. As a matter of fact, this is a Avionics bay from a 4-inch AIM 9L Sidewinder rocket. It's an 80% scale model. I used phenolic tubing for the airframe and the Avionics bay. And the kit is almost completely ready, except for paint and decals. I do have some wiring that I have left to do in the Avionics bay, and I'll describe that. So, okay, so here we have a 4-inch Avionics bay. So obviously we've got a large eye bolt, which is going to attach to both the upper stage on the one end, and then another eye bolt on the bottom, which is going to attach to the booster. And you can see what I've got here are charge cylinders. Now, these charge cylinders were 3D printed by myself. I designed them. You can see, if you look very closely, you can see there's a hole. That hole allows the business end of the igniter to go into the charge cylinder, where I would be having packed 4FG black powder, and then some dog's breath on top of it and a piece of tape. And then I've got a terminal block here, so the wires are going to come out from inside the Avionics bay, connected to the altimeter for the drogue and main parachutes. Drogue on one side, main on the other. And then the other side of the terminal blocks is, of course, is where I'm going to put in my discarded initiators, which are going to be used, right? So after you use them, you only use them for one flight, and then you throw them away. Okay, so let me open this. Another trademark of Pap's rocketry design is some kind of a switch to allow field activation of the avionics. So when I press the switch down, and that would be in the flight ready, so this is up, this is down. So when I turn the switch on, which is flipping it down, aerodynamic forces are going to tend to keep the switch in the same position, in the on position. Okay, so when I activate it, and you can see I've got a blue LED, which indicates that we have power to the device. Devices in this case. I've got 2 Avionics cards. One is from Blue Raven, and which has 4 outputs, which you can control. And then the other is a MissileWorks RRC3 Plus. Okay, so I'm just going to take this apart so that we can see what's on the inside. Okay. So you can see, just pull all these wires out of the way, is we've got a 3D sled, which I printed on a 3D printer. I've got the terminal blocks here that took care of all the wiring for both devices. Flip it over, you can see I've got slots to put in LiPo batteries. And here, you can see is the MissileWorks RRC3 Plus altimeter, and this is the Blue Raven altimeter. 4 outputs, 3 outputs. This will be my main altimeter. The Blue Raven will be a backup. Another reason that I installed the Blue Raven is that this altimeter also has an inertial measurement unit, and you can get roll rates about all of the degrees of freedom, which I'm interested in understanding how the rocket actually performs aerodynamically as it when it's under powered flight. And then this is a Bluetooth module that I purchased to go with the RRC3 Plus. And what this allows me to do is to wirelessly connect to the application which I have installed on my laptop computer, and that will allow me to wirelessly configure the altimeter, and I don't have to dismantle it. Okay, and so that is basically it. I'm going to have to drill some holes in each side of the bulkheads to allow the wires to come through from the altimeter, and then I will pretty much be ready for flight. So I hope you enjoyed this little sneak peek into a LOC Precision 4-inch Avionics bay. See you next time on Pap's Rocketry.